Let's say we want to work on number 2. Y is equal to 2u cubed. So if I want to take y prime, that is the derivative with respect to x, I will use the power rule on this, but I don't stop there because this is a function of, this is in terms of u, but I want dy by dx. So I differentiate it first, which is 6u squared times what is the derivative of u with respect to x? Well, because u is equal to 8x minus 1, u prime of x is just 8. So I substitute now, it's 6 times u squared times 8, which is 48 u squared. But remember, we are differentiating with respect to x. So all I need to do is just put there 48 times, what is u? 8x minus 1 whole thing squared. Okay. Now, another approach that we can take is if I substitute right away what my u is. So y is equal to 2 times 8x minus 1 cubed. Now that y is a function of x instead of u, I can go ahead and take the derivative directly and still apply the chain rule. So the whole picture is 2 times the power rule. So what we'll do now is 2 times 3, apply the power rule on the big picture, okay? So it's 3 raised to the second power now. But I don't stop there because now I have to take the derivative of what is inside. So this is 8x minus 1, 8x minus 1. So this becomes 6 times 8x minus 1 squared. And then I multiply by the derivative of 8x minus 1, which is just 8, because the derivative of a constant is 0. So that is equal to 48 times 8x minus 1 squared. So every time you apply chain rule, you work on the outside going in. So it's like you're zeroing in from the outside coming in. Okay, let's do suppose we do number 3. Y is equal to the sine of u, where u is equal to 3x plus 1. So dy by dx is equal to dy by du times du by dx. So what is the derivative of y with respect to u? It's the cosine of u times the derivative of u with respect to x. It's just 3. And since we are looking for a function of x, all I need to do is substitute what is the argument of cosine with respect to x. I'll just replace it by 3x plus 1 and times 3, or 3 cosine of 3x plus 1. An alternative way of doing this is first making the composition y is equal to the sine of whatever your u is. You can go ahead and substitute. It's 3x plus 1. So what is y prime? We are differentiating now with respect to x. Look at the whole picture. The whole picture is the sine of 3x plus 1. So we take the derivative of sine function. So it's equal to cosine of 3x plus 1. But we don't stop there because cosine has a function embedded in its argument. So now we differentiate 3x plus 1. We multiply by the derivative of what's inside. Okay, so that's equal to cosine of 3x plus 1 times 3. We arrive at the same derivative. This is one common mistake that happens is whenever when we are applying the chain rule, we have a tendency to take the derivative also of the inside at the same time. So y prime becomes cosine of, then you differentiate the inside as well. But that's not the case. So this is not right. Okay? So that's not correct. So do not do that. So first of all, what we do is we look at the whole picture, the big picture, and take the derivative of the outside, which is sine, derivative of sine is cosine, of the argument. And then we multiply by the derivative of the argument, whatever is inside, that the cosine is trying to evaluate, or of the function. So the derivative of the inside is the derivative of 3x plus 1. So you multiply that, that's 3, and just a rearrangement of terms. Okay, so let's move on. Suppose we want to do number 7. Y is equal to the tangent of u, and u is equal to 10x minus 5. Let's take dy by du. Alright? Dy by du is equal to secant squared u. And then here, du by dx, simply 10. It's really 10 minus 0, so it's 10. So if I take dy by dx is equal to dy by du times du by dx. So all we do is just substitute the rest. So it's secant squared u times 10. Okay, that goes here, that goes there, and then we put that 10 in the front, because we always put our constant coefficients in the front, secant square, and then go ahead and substitute 10x minus 5. Okay, again, suppose we do it the other way around. An alternative way of working on number 7 is substituting the value of u right away into y. So y is equal to the tangent of, its argument is 10x minus 5. Look at the big picture. So what is y prime? We differentiate the tangent function. So what is the derivative of tangent? It's secant squared of 10x minus 5. And then we don't stop there. We take the derivative of 10x minus 5. So that's equal to secant squared times 10x minus 5 times the derivative of 10x minus 5 is 10, which is equal to 10 times secant squared 10x minus 5. What about number 8? In number 8, okay, y is equal to negative secant of u. And then u is x squared plus 7x. So dy by du is equal to negative of, what is the derivative of secant? Secant u tangent u. Okay, now here we're looking at our function u with respect to x. The derivative of u with respect to x is just 2x plus 7. So now I want to get dy by dx, and so I take the derivative of y with respect to its variable u times the derivative of u with respect to x. So it's minus secant u tangent u times 2x plus 7 And of course, everything has to be in terms of x. So that's negative secant of x squared plus 7x tangent of x squared plus 7x times 2x plus 7. Okay. Again, let's use the other method. So what we'll do is go ahead and apply directly your composition so that y is equal to the negative of secant of, what is u? X squared plus 7x. So taking the derivative of y with respect to x, look at the big picture. The big picture says it's a secant function. So it's the negative of the derivative of secant function is secant of x squared plus 7x times tangent of x squared plus 7x times the derivative of x squared plus 7x. So that's equal to negative. I think we were going to run out of room here, but let me just write it down. It'll be, go ahead and write it down here. It'll be negative secant of x squared plus 7x times tangent of x squared plus 7x times the derivative of the arguments of these functions. So it's 2x plus 7.